So the demo app that we're going to use, so first of all, a little look at the GitHub repo. So as I said, all the slides, the code, the demo app, the scripts, everything is in this repo. The repo has been around since June of last year. And in this repo, we have the dockercoins directory, which contains the demo app per se. This demo app has multiple components. There are like 4 code components, 4 microservices, and there is a Redis data store. The app is described by a compose file. A compose file is a YAML file that contains the services composing the application. And for each service, we have either an image definition, which means that this means I want a service named Redis, and this service should be using the image Redis that lives on the Docker Hub, on this public library of available images. If I wanted to have, let's say, a PostgreSQL database, I could have a section saying DB and then image PostgreSQL. The other 4 services don't have an image definition, they have a build definition instead. This means instead of pick that image from the library, it means build that image using stuff contained in that directory. I'm the kind of person who tends to be very boring when I name things. So when the service is named food, the directory is food. That way it's easy to remember what is where. So in that case, for instance, I have the RNG service is in RNG, the web UI is in web UI, and so on and so on. And in each of those directories, we have a little bit of source code and a Docker file. The Docker file is the recipe that describes how to build this specific container image. And then there is the source code for the microservice. If you have used Compose before, in particular, if you've been like using Compose for a while, but you have not followed exactly what was new and everything, you might be familiar with the Compose V1 file format. Now we tend to favor the Compose V2 file format, and the difference is pretty small. Basically, in the V1 file format, you only have the services section. So directly on top of the compose file, you have your services. In the V2 now, all that stuff is in a services section. There is a version section, and you can have additional sections to define custom networks, volumes, and leaving some room for further extension. So one interesting thing to know is how do containers discover and talk to each other. Containers can have network aliases. In the first time this feature was introduced, Docker would just pre-populate /etc/host in the containers, which was a really crude way to do it, but it works. And now Docker is using an embedded DNS server that is dynamically populated, so that, for instance, in one container, you can kind of inject the fact that the name Redis should resolve to the IP address of the container running the Redis service. And that's super convenient because that means that you can have the same stack, like multiple copies of the same stack running side by side, and they all have a container named Redis, but it's a different container. And so in the first stack, when you resolve Redis, it gives you the IP address for the Redis container in that stack. And in the next stack, when you resolve Redis, it gives you a different IP address so that it's the IP address of Redis in that specific stack. This means that in the code, we connect to other services like this. When we want to connect to something, instead of putting an IP address or FQDN or whatever, we just put this short name, and we know that Docker will resolve that name to the IP address of the container running that service. So this application, what is it? So it's a Dockercoin miner. So fortunately, you can't buy anything with Dockercoins. They are worthless. Otherwise, I could probably retire by now. The way Dockercoins work is that we have a worker that does an infinite loop. And the worker talks to 2 microservices. One of the microservices, RNG, is a random number generator. So when you connect to RNG, it gives you like random data. So the worker does that, it gets some random data, then it posts the random data to the second service, which is Hasher, and hasher computes the SHA-256 and returns the hex digest. And then we increment the counter to indicate, hey, we've done the main loop once. And then we get random data, hash it, increment the counter. Get random data, hash it, increment the counter, and so on and so on and so on. So it's completely useless, but it has pretty high educational value, I hope. And there is a web UI that basically looks at the counter and computes the real-time speed at which we are doing the main loop in the worker.